So if people didn't meet him last week, if you're new this week, this is Devin Jagasaria, Principal Software Engineering in Software-Defined Networking in Azure.
Thanks, Christina.
Mm-hmm.
So let's start with a bit of a recap from what we discussed last week. We discussed various scenarios in which traffic generated by Azure workloads goes over SLB muxes onwards to the destination, and the return packet can go via a different mux. We discussed how mux being a shared entity, we don't want to put too much bandwidth on it. So I'm sorry, just give me a second. Yeah, I'm sorry if I sound terrible. I have a bad cold.
Oh.
Uh, so yeah, and so as an attempt to bypass the traffic, bypass the bunch of bandwidth that goes over SLB mux, we have something called ICMP redirects. In this case, when the mux sees a new connection flowing through it, it would send an ICMP redirect to the sender of the traffic, informing the sender about what were the various decisions the mux took for that packet, how it decided to route that packet, and that information is conveyed via an ICMP redirect packet. And using that information, the sender workload can fix up its flows and set the appropriate destination metadata in the packet. Specifically, it sets the outer destination IP address. It sets the inner destination MAC address. In some cases, it changes the GRE keys or adds a GRE encap to make this packet work end to end, bypassing the SLB mux. So that's a bit of a recap on how the fast path is expected to work. We saw what these ICMP redirect packet looks like, and specifically to make fast path work, here's how the interpretation of the ICMP redirect packet should be. The redirect packet, it would contain a redirect option coupled with the redirect info. This information would be sufficient to extract the 5 tuple of the specific flow that we are targeting for fix up, and it also has the information about what the fixing criteria for those flows should be. So what fields should get fixed up is all contained in this redirect packet. We spoke about the VIP ILPIP scenario. This is where the sender workload will be sending a non-encapped packet passing through when the transformation is done by the DPU, the packet is still unencapped. But when the redirect packet comes in with the specific fastpath GRE key, it informs the DPU about that the ongoing packet, the subsequent packet should add a GRE encap with the specific GRE key and the parameters as described over here. This is how the post fast path flow should look like for this scenario. Another scenario we discussed was the private endpoint and service tunneling. Over here, the packet generated by the workload VM after it gets transformed by the DPU already has an NVGRE packet, NVGRE encap. This is IPv6 within an IPv4, and the subsequent fast ICMP redirect packet would necessitate changing just the destination address in this scenario. Oh, and the inner MAC as well. The destination address and the inner MAC, the GRE key remains the same. This is the new stuff over here. We didn't discuss this scenario last week. This is another flavor of traffic going via SLB mux, and the fast path for this is handled a bit differently. This is specifically for internal load balancer. So internal load balancer, as you guys know, is part of the VPC, and within the VPC, we usually talk. Usually the underlay is VXLAN. So similarly, for any packet generated by the workload when it passes through the DPU, the first packet, it will always have a VXLAN encap with the VPC VNI. The This is destined towards the mux. That's the when we do a mapping lookup for the destination CA, which is the ILB CA in this case, we will always get a mux whip where the packet should be directed to. And so we know that this packet definitely passes through mux. And once mux detects this packet's coming through, it would send this specific ICMP redirect. And the post action of this would be to maintain the VXLAN in cap, and just that the destination address gets changed to the end host bypassing the mux. So the parameters for this scenario are the pre-fast path flow will have a VXLAN in cap out VXLAN in cap packet in the outbound direction. The VNI would be the VPC VNI. The redirect format will be ICMP v4 in this case. The specific GRE key of the ICMP, oh, this should have been v4. I'll check. I'll fix that. Will be 254. And all we are doing over here is we are maintaining the same VXLAN and cap from the pre-fast path flow with the same VPC VNI. We are changing the destination outer destination address to whatever we get in the redirect info, and we change the inner destination MAC to whatever we get in the redirect info as well. Some packet captures which show us the exact same behavior, the TCP SYN packet, which would which would be going to the SLB mux. The redirect packet over here coming in with the specific it contains a GRE key, but we specifically say not to use this GRE key. We use the same VPC VNI as before, but the PAV4 and the VMAC is what we fetch from these fields. And well, we can see over here we choose after the ICMP redirect has gone through, we will change the outer destination address for this case. So those were the main scenarios that we need to support FastPath for. We specifically call out that this is purely a data plane operation. The control plane is not involved in configuring any of the FastPath parameters, except for the knobs where we want to switch the behavior on and off. So for that reason, we don't have specific SCI APIs over here passing the FastPath configuration. We do have these live the knobs for um, controlling which behavior we want to switch on and off. So specifically, I categorized it into three based on the above three scenarios that we discussed. Those were the three flavors of FastPath. So one toggle for handling ICMP redirects with GRE key 253. This is the ICMP v4 format. One specifically for ICMP v6 format with GRE key 254. And one again for IPv4, ICMP v4 format for GRE key 254. These are the three fastpath knobs that we will use to switch off the behavior. The default should always be enabled. And the only reason why we might choose to switch it off is if we look at the metrics and we see something is not wrong or something is wrong, or if we find some connectivity is not working. So here are the three knobs defined in our enum. The counters is something I wanted to spend a bit of time on. Any questions till this point?
No questions from me. Really, really good recap. How about anyone else on the call? Nope. Go ahead, Devin.
All right. So the counters are categorized into the port level counters, the ENI level counters, and the flow table counters. Specifically, the visibility that we want over here is how often are we receiving such ICMP redirect packets? Whether these ICMP redirect packets were able to fix up some flows, or whether the 5 tuple mentioned in the ICMP redirect ended up with a flow miss. And just the amount in certain situations we'll be using the DPU for a very specific scenario. in those scenarios, we expect all the traffic to be fast path, right? All the flows should ideally be on fast path. So so we need some visibility into what number of flows are currently post fast path flows versus pre fast path flows. So that's what we will discuss this. So the first one is simply for the number of ICMP redirect packets that we received. And subsequently, we log the size of those ICMP redirect packets as well in bytes. The other one is we received an ICMP redirect packet, but we could not figure out which ENI it is intended for. So this helps us log that metric along with the number of bytes that the ICMP redirect packet contained. Then we have some per ENI metric for the number of fast path packets received. So we usually log packets received, byte received, packets sent, and byte sent, right? This one specifically talks about how many of those packets were courtesy of fast path. So similarly, number of packets and the number of bytes. And lastly, we have the flow table counters. First one is the number of flows that were redirected due to a fast path packet received. Ideally, this should be the number should match the number of fast paths, the number of ICMP redirect packets that we receive on each of the ENIs should match, aggregate that over the flow table. This metric should match that number. Then the number of times we received the fastpath packet, but we did not find entry in the flow table for that redirect packet. Ideally, this number should be 0, but there could be cases where the connection terminated right after the SYN, but the MUX still had a ICMP redirect packet on the way, and so on. So if not 0, like a very minuscule number over here. And the last one is the total number of active flows that that are on the DPU that have been successfully switched to fastpath post an ICMP redirect packet. And that's it. Yeah. So that was the entire ICMP flow redirect for fastpath scenario that I wanted to discuss. Any questions about the metrics?
So that
All right.
is a ton of work. If anyone does have comments or I would like to comment on the PR, did you put the link to it in the chat window, Devin?
I'll put it, yes.
Okay, great. Yeah, so anyone have questions on this one? Okay, great. Well, I think the scenarios would be super useful, Devin. And are we going to write tests for these? Are we going to write tests to make sure it works properly?
I think at some point we will need to. Rif, I see you are on the call. Do you know if tests were part of the roadmap for this change?
Roadmap.
Tests. Are we gonna
Tests.
like the Dash community? Like they're always interested in testing, and testing the scenario. So I was wondering, I wonder if we would request the community to write tests, or do we write tests for this?
I think anyone actually contributed. Then yeah, then is all good. Yeah, I don't have any anyone like dedicated in my mind at this very moment. So
Gotcha.
It's more like handling the packet and right now what we have is actually we have a data plan app that can actually handle the packet and it can manipulate the flow in the way that we want. We already have the flow APIs. So I think all the infrastructure is actually all there. Just like we don't have the code that handles a packet. Yeah.
Thank you.
But Riff, the SONiC management test is needed to, complete the integration on the vendor's side, right? We cannot claim that the feature is working fine unless we run the SONiC management test that can confirm that. So how do you suggest to go here?
Right now, what I have in my mind is that we can probably like depends on the project schedule. We can probably like take it offline and see how to move forward. But I don't have anyone like right now in my mind that currently assigned for this work.
Okay, I see. Thank you.
Yep. No
Yeah.
problem.
And I think the idea was to present these scenarios in case, anyone in the community had a passion for testing and might propose a test. Yeah, Riff?
Yeah.
Mm-hmm.
Yeah, because I think I think right now all the requirement is really clear. Like all the packet format, everything, like the counters, toggles,
Yeah.
Everything's explained like really clear.
Yeah. Yeah, it's very clear. Thank you. All right. Thank you, Devin. Appreciate it. And I'll send out notes this week. And next I had Prathima from Intel was looking to give us a quick synopsis on the open sourcing of Tofino P4. If you were ready, Prathima?
Yeah, thank you, Christina.
Yeah, no problem.
Can I share?
Of course.
Hi everyone, this is Dave Chatterjee. I'm Prathima's manager. Just wanted to share a couple of words here. I think pretty much all of you know that the active development on Tofino Silicon has stopped, but there is still a lot of interest in the community to keep going with the parts that are available. However, some of these are still somewhat encumbered with NDA requirements and other things. So we decided to open source everything to give the development community free access to the entire software stack. I think this can definitely enrich the P4 development across the world. And Prathima is going to present the details of what exactly we open sourced and where are these located.
Thank you, Dave, for the intro. So yes, so basically Intel has been very active in the P4 community, and the contributions have been in multiple folds from the compiler perspective, front end, back end, mid end, and tools mostly contributing to the P4 Lang, P4C backends, SONiC, IPDK, DDA. From the Tofino software stack perspective, in the past few years, we've had many requests for people who are trying to do an academic community as well as from the customer front. So customers do have access to our SDE, but that doesn't include the entire sources. And that has been like a request for a long time. And the initiative to open source Tofino stack has been immensely triggered by one of that as the primary reason. And the other one is as Tofino is ending life, we wanted to find a place to migrate the code base and have the community support leveraged so that there is continuity for the product itself and the software as well. And to have a place where everybody's work is showcased and there is contributions from everyone else in the community as well. That is the primary motivation. So how did we do this? Typically, when we release our hardware, we give the SDE package, and that is something available for all the customers. And all the components that are included in this package are mostly all the software components. And so These are useful for programming the ASIC itself, but also we have other things like the simulator. So I'll just give like a brief overview of what are the components here and how do they map to the open source repository. Diagnostics is mostly to just do device diagnostics that is included in the BF Diags package. Then we have BF drivers, which includes the libraries to manage the ASIC and the APIs to configure it. BF utils and target utils and target syslibs are utilities and libraries that are used for low-level configurations. Compiler itself is the compiler backend for both Tofino 1 and Tofino 2. P4 examples are a rich set of programs that describe each feature, how it can be written in P4, how it can be compiled, how tests can be written to exercise it. P4 obfuscator is a tool that can be used to scramble the original P4 and use it to sharing purposes. This could be useful, especially when you want to protect your IP and still want to be able to discuss on any issues or bugs. PTF modules itself is like a PTF package that supports testing frameworks, and PTF test cases are like a high-level abstraction of Python that can be written to exercise the control path and data path of the device. Switch P416 is a suite of profiles. Mostly these are for Tofino and Tofino 2. And when we have our customers, they use this as a baseline and then they add features on top of it and make those as pipelines that they can use in their model. And whenever we release like software updates, they just make sure that it still compiles and the tests are run. And every time they have additional features, they keep updating this. So this Switch P416 serves as a good baseline if anybody is trying to see how to configure and program the pipelines. Tofino model itself is like a simulator that can be used to just verify if the P4 that is written has the functionality that is supported, and the PTF tests can be run in adjunction with the model and driver. This gives like a good use case to validate things before we actually run on hardware. So any questions so far, or I can take the questions at the end?
So you have released the Tofino, Tofino model as well, including its source?
Yes, I'll go over the details.
Cool.
So how is this done? This is done like a two-part process. First thing, from the Intel perspective, we had to create our directory structure that would map to the P4 lang. We had discussions with the P4 technical steering committee, Andy, Fabian, they have been instrumental in this effort. We tried to come up with a proposal to identify how we wanted to do this. So Deb, myself, Han, Glenn, Shiv, many of the folks who are still with Intel at that time, basically we tried to have this discussion to identify what is the path moving forward. And the proposal is to have like a mirror repositories that would mimic what we have at Intel side. But these repositories need to be cleaned and basically the code needs to go through the OS open source product approvals, so that we are not leaking any sensitive or customer information and any of the unreleased targets. That has been done. So P4lang BF P4C was an internal intermediate repository. P4lang BF model was the model source repository, and Open P4 Studio is like is a repository, basically staged repository that becomes the final Open P4 Studio. From the BF P4C, the Tofino backend has been integrated to the P4lang P4C backend, and the assembler code has been integrated with the Open P4 Studio. And BF model sources are present in this repository. The executable is included in the OpenP4 Studio, but there is effort to include the source in this structure itself. I'll go over the next details. But basically, OpenP4 Studio now mimics this structure, which has all these components. Right now, Tofino model points to a binary, but we have a PR up for integrating the sources as well. What are things in progress? As I said, we are integrating the source code inside the Open P4 Studio repository for the optional build option, because model itself will take a long time to build. So if anybody just wants to use it as is, the binary is available, or the source code changes can be done and integrated. From the compiler perspective, assembler is still belonging to the OpenP4 Studio, but there have been PRs up to integrate this assembler source as well inside the P4lang P4C to simplify the build process and to have a single place where all the targets are available. Tofino tools, P4 TestGen and P4 Smith have been integrated with the P4lang P4C backends as well. So some of the items in blue are the things in progress. And as I mentioned, Andy and Fabian have been very helpful in leading this and making sure they're heralding some of the pull requests and customer queries, as well as interest from academic community. P4 Studio itself is like a complete package, but there is a P4 Studio like a wrapper script that can be used for many functions, like installing the dependencies or configuring the ports, or package extraction for like the BSP package that we need to extract for the configuring and running things on the ASIC. We could create sample profiles that can be applied, or create a profile based on whatever configurations we want, and a P4 Studio profile apply command can just be used to run this configuration. Build just to build any program, or help is pretty self-explanatory. These are everything is included as part of the OpenP4 Studio, and on a plain Ubuntu environment, this can be installed and run. There is one caveat though. So for that's what I wanted to mention in the challenges as per. The Tofino model is what is included in the OpenP4 Studio, and the driver builds for the Tofino model. Now, if we want to build the driver for the hardware, there is some third-party references from some of the third-party vendors, which have some firmware APIs and registers that are required. At this moment, we host them in Intel RDC document center, that all those files can be downloaded and replaced. So these are part of the SDE that we generally give. So we have been in discussions with the vendors to see if they can allow us to include them in shared library form so that we can include it. And every time there is some change to the internal files of the driver, these need to be reintegrated. That is something that has been ongoing, and as we have updates, we'll let you know. From this release has been made on Jan 15th, and we are very grateful for the tremendous interest and engagement from the open source community. We also removed the blockers for academia. So basically, we had to go through a ICRP review, that is an Intel proprietary review that needs to verify the Intel IP and Tofino specific hardware details. That has been waived off. So people are they can produce their work. Basically, if there are like we had seen issues where there are kind of making changes to the code and all. So we need to have pull requests validated and all. We are trying to do that, and mostly it's been from the community effort. And it has been a huge team effort. There have been many contributors since the beginning of the Tofino days, and there are contributors still actively contributing at this point as well. Thank you, everyone.
Yeah, Prathima, thank you. It's interesting that, even people were pinging me, asking me, if I could talk to you guys and see if we could, have more information about the open sourcing. I think a link was referred to me about your announcement for doing that. So thank you for that. I'm curious if people were interested in following the repo to look for changes or anything. Would that be the P4lang P4C repo, or is
It
there
would be P4lang Open P4 Studio repo. So that would be the
there
repository.
it is. Okay, got it.
Yeah,
Okay.
and the P4lang P4C is the one where the compiler sources are hosted.
Got it.
So, I have the links in here as well.
Wonderful.
And this one is Deb's announcement that also talks about all these links as well. So they are already provided in here.
Awesome. Yeah, and that's the one we saw. Okay, great. So if anyone's interested in following or learning or contributing, that's where you would go. Yeah.
Yeah,
Any
I'd recommend with the Open P4 Studio repo first, just because P4C has all the other backends and the issues kind of get mixed up. So if you have anything confused, starting in the Open P4 Studio for issues and questions is probably the best place to start.
Okay. Sounds good. And the importance of this is just that so many hardware devices are running this hardware and using this programming model, right? And with it being end of life, they'll be able to do it themselves.
Yes, that is one of
I'm
the
just
major
summarizing.
things.
Yeah.
Okay, got it. Sorry.
Just summarizing. Okay, great. Thank you very much. Appreciate it. Any questions for Prathima or Deb?
Hi, this is Chris. Thanks a lot for the overview. I was wondering, does Intel have plans to, let's say, allocate people to kind of support the open source? Once this is, let's say, released and done as far as you're concerned, will people still be kind of assigned to contribute in a community fashion? Because you guys are still the experts, so to speak.
From the customer support, we still have ongoing customer support that is provided. And every time there are changes that are made internally, we are making sure they are pulled back to the open source. And things have been, the expertise has been reducing day by day. So, but still, whoever is present at Intel, we are trying to do our best here. Deb, anything else you wanted to add?
No, exactly what you just said. We have some capacity, but really very limited capacity.
Yeah.
And we'll keep supporting with that.
Okay. Kind of best effort. Thank you.
But one minor comment, I've noticed Chris Dodd jump in from NVIDIA on some questions now and then. So that's purely volunteer effort though.
Yes. Chris has written a majority of our compiler and assembler stack. Yes. And thank you, Andy. Thank you, Andy, so much for heralding everything.
Are you talking about Chris Dodd? Chris Dodd?
Yes. Chris Dodd.
Yeah, not this Chris.
Yeah, sorry. Chris Dodd is now at NVIDIA, but he still has chimed in public forums on Tofino backend compiler questions and issues in the past month.
Got it. Thanks.
On a volunteer basis.
Any other questions, guys? Well, thank you, Deb. Thank you, Prathima, Andy. Appreciate that. I'll go ahead and include the repo in the notes I send out too, just for awareness.
Thank you, Christina. I'll share the slides as well.
Oh, thanks. Could you upload them to the slides folder of the repo if I give you the name of the repo?
Yes, I'll do that. Thank you.
Cool. Thank you. Last thing, so Satya from TCS, since we're all on the call, had a quick question about the issue that she's attempting to resolve for us, issue number 38. And it was the northbound GNMI. And are we mapping our dash to align to OpenConfig? So this was maybe, Satya, maybe you could recap your question here.
Yes, please. Thank you. Actually, we were trying to come up with a ACL OpenConfig mapping to the this issue. We started looking into the code. In the current implementation in the SONiC Dash, it seems it already has some SAI mappings to the ACLs. But our observation, it is not, it is unclear for us whether it is compliant to the OpenConfig or not. Why we had this doubt? Because the current implementation is particularly in terms of the open tables and rules as per the current implementation in the SONiC, but as per the OpenConfig, it should be something like actions, the ACL entries, sets entries, kind of stuff. The doubt here is, should we need to, the scope of the work is to comply as is the OpenConfig standards. The difference here is only with the ZARCON naming convention that we are observing in the hierarchy of the attributes that were there in the OpenConfig or not, as is in the SONiC current implementation. Do we need to map it, or how it would be actually?
Right. And I hadn't heard that we were aligning. Maybe I could lean on Camille here for a second from the SONiC team. Would you happen to know, Camille, or have a pointer?
Yeah. Yeah. Yeah, I'm here.
Yeah, I can hear you.
Yeah, so what was the question?
The question, Satya, go ahead. But basically, it's do we need to align? Satya, I'll let you ask the question.
Sorry, I don't quite get that.
So they're trying to take on issue 38, and they're wondering if they need to make the Dash ACL schema and SI mapping compliant with OpenConfig, because there are differences in what the table structures and the format. SONiC uses one format, OpenConfig uses another.
Yes.
That I'm not familiar with the OpenConfig, so I think I will be not able to answer that question.
Mm-hmm. Okay. I would assume, Satya, that we would want to go ahead and maybe not worry so much about aligning with OpenConfig, but let me try and chase that down internally with the SONiC team.
Sure.
If because I don't see Riff on the line here, and I'm not sure whether anyone else would know on this call.
I saw that
Okay.
I mentioned the hyperlink there, the configuration requirement description link. It says the document and the whatever the documentation they are speaking about the ACLs, they mentioned that they are using open config structures only. But the main concern here is that the naming conventions are different. Do we need to follow the open config naming conventions, or we have to restart the work in the Dash repository for this ACLs, or if we want to do it again, or the current implementation is sufficient? What are the ACL configuration we are seeing in the Dash is already present? There are some gaps here.
Okay. If we can get an answer there. Okay, great. I'll stop sharing my screen. Did anyone else have a PR or issue they wanted to cover today? Okay, no. So thanks everyone for coming. It's 40 minutes in, so I can give back about 20 minutes of your morning if you like. And I'll go ahead and compile the notes and send them out, since I was awful and missed it last week, but it was President's Day. So thank you everyone for coming.
Thank you.
Thank you.
Thank you. Bye.
Okay,
Thank you.
appreciate it. Thank you everyone for contributing. Bye-bye.
Thank you. Bye.
Bye-bye.